Hello, and welcome to session 3 of the intermediate track for Beam College. Now, in sessions 1 and 2, we introduced the Run Inference framework and the model handler class that we use for inference in Beam. In number 2, we talked about how to choose models and adapt a model to Beam to be used in a Beam pipeline. Today, in session 3, we're going to go over a high-level overview of the example pipeline that we'll be constructing in our sessions 4 and 5. So I introduced this pipeline in session 1, and basically what we're trying to do is build a pipeline that will take as the input on one side calls, audio data, for customer support to a bank. Then we're going to take those help support calls, transform that voice file into text. We're going to classify the text as to what kind of support they're looking for. And then depending on that class they're assigned to, send them to an LLM. And in real life, we would use an LLM fine-tuned for that particular use case. For this example, we're going to use probably a variety of LLMs that are not actually fine-tuned, but that's what we would do in real life. Then we'll take the output of those LLMs, turn it back into voice. So we'll use a text-to-speech model here. The idea being that in a customer support situation, you could have a model that takes the customer audio, takes it all the way through this pipeline, and then produces audio output that you can return to the customer. Given the latency of the pipeline, that might need to be a message you leave or a callback. Unlikely to be able to do that in real time in a Beam pipeline. So now today we're going to dive into each of those steps and talk a little bit about what we're going to do in a more concrete way. So let's begin with the help center phone calls. Naturally, we need to ask ourselves, what format do those files come in? And what I'm trying to do here is show the kind of questions you would ask yourself when you're building a pipeline, given that you know, of course, for your business use case, how to arrange things as an order of steps and needs. I'm talking about how to translate those steps and needs into concrete data you'll use to actually implement your pipeline, which we'll do in sessions 4 and 5. So these are some questions that we'll need to ask for the different steps. For the input, what is the file format? Where are those files stored? And in this case, it's audio. We need to know how long the audio clips can be, because that could influence our choice of model. Luckily, we have answers. So for our pipeline here, the file format, we're going to be using WAV files. They're going to be stored in a Google Cloud Storage bucket, and we're looking at a length of 1 to 2 minutes per clip. The next thing we have to figure out is about that speech-to-text model. What kind of model are we going to use? The model will also help us answer questions like, where will we get it? What framework is the model written in? What model handler will we use? And how will we pre-process or sometimes post-process the data? So for the voice-to-text model portion of this pipeline, we're going to be using a model from Hugging Face. This is the OpenAI Whisper Small model. We're choosing a small model because that lets us run it more effectively in the Google Colab environment we'll be working in. We're going to get the model and the weights from Hugging Face because Hugging Face is, in my experience, the biggest model repository, and it's also the easiest to use. Documentation varies per model, of course, but overall, I found it gives me the quickest path from translating my need to a model that I can instantiate in a Beam pipeline when I go through Hugging Face. Hugging Face gives you choice of frameworks, so I'm going to choose PyTorch as the framework that we're going to use. It's a fairly arbitrary choice. Hugging Face models are often available in TensorFlow, PyTorch, and sometimes in JAX formats. JAX really more appropriate to running a very large model, probably on a TPU environment. TensorFlow or PyTorch, I prefer PyTorch. I find it easier to use, and their dependency management's a little more straightforward for me than TensorFlow, but both choices are perfectly fine. Then, of course, once we know the source of the model and the framework, that makes choosing the model handler very easy. So here we'll be using the Hugging Face model handler, specifically the Hugging Face pipeline model handler. And we'll see more detail about this in the next session. But basically, the Hugging Face pipelines allow us to implement the inference in an even more streamlined manner than downloading the model and running it just as a PyTorch model, or even using the regular Hugging Face model handler. Finally, how will we pre-process the data? We've got that file, it's being turned into text, but the length is longer than the context window of the Whisper small model. So how will we handle that? How will we chunk the data or assemble a longer audio sample into one piece of text? Luckily for us, the Hugging Face pipelines implementation can handle all of that for us. So it, under the covers, can do the chunking, the coding, so that we can basically provide only the data and some basic arguments, and we'll get text from the WAV files. So the next step is one that is, again, for the actual data we're using, a little bit contrived. But we want to have a classifier that examines that text and says, what kind of call is this? What is the, in this case, what's the user trying to do? Are they trying to change their address or order a new card, get their account balance, these kinds of operations? With this data set, again, honestly, it's overkill probably to do this classification and send it to an LLM. But in a real use case, often you may have things like a recommendation model. And the recommendation model might want to classify the user or the geography or the time of day or the language even. And depending on what class something is, whether this is a Japanese request or an English request, you might send it to a different fine-tuned model that is downstream. You might have a model that can give a recommendation for Japanese pop music to the Japanese listener, but give a recommendation for American pop music to the English-speaking listener. So this is more of an example of something you would do in a real business process. And it's a step we need for the next step, which is actually sending the data to different models based on a characteristic of the data. So here we're going to classify, and then depending on the class something is in, send it to a different model. So for the classifier itself, we have a small number of classes, 8 classes, pretty basic text data. So what we're going to do is actually train our own classifier. That won't be part of this exercise. I'll have a trained classifier, but I'm not taking a classifier from an existing source because I want to fit it to the data that we're using in our pipeline. We're going to get the model by training it ourselves. Training an XGBoost model is something you can often do on a single machine pretty effectively. We're using the XGBoost framework. This is a powerful framework that's specialty is building things like classifiers for a small number of classes. What model handler? We'll use our XGBoost model handler pandas that accepts a pandas data frame as its input. I want to showcase how you can use pandas. It's a very powerful, very familiar tool for a lot of Python users. and this shows how to use pandas to give your input to the XGBoost model handler. Now, that fan out, aligning finding what class one of these phone calls is, and then sending it to the appropriate model is something that's a little tricky. And in many instances, you would have to write a case statement or a complex if-else loop. But instead of having to do that, in Beam, we have functionality that allows you to define this mapping using something we call a keyed model handler. So you can basically define how to relate one set of outputs to one downstream model. This is a fairly powerful capability that Beam has, and I believe the Beam implementation is very straightforward, but we'll go into that in depth probably in session 5. So keyed model handler, and we have this notebook talking about how to use per key models if you want to do a little bit of advanced reading. Now, like I say here, we'll be sending those calls, that text, to a different model depending on what kind of information it needs. In real life, we would have those be fine-tuned models that could provide good output for each of those. But for this example, I think we're going to just try and pick a variety of small LLMs, and we may get some entertainment value from how they respond to these different requests. We can compare them a little bit. So for the models, we'll be choosing small LLMs. We'll still get these from Hugging Face because that's got the biggest repository of a variety of small LLMs. I'll stick with the PyTorch framework so that we're not doing different things in different parts of our pipeline. And here, instead of the pipelines handler, we'll probably use the regular Hugging Face model handler because the LLM use case is a little more straightforward than something like audio when we have a short text, as we have in this exercise. Finally, at the end of the pipeline, we've got some response from the LLM, and that's going to be in text once again. And we want to transform that text response back into voice, with the idea that that's how the user gave us their input. So we will do the courtesy of returning their output in the form of voice as well. Here, of course, we're using another model. And I think we're going to use the MMS TTS model from Facebook. And TTS is text to speech. They have a fairly small model. I think it'll fit in our Colab instance pretty well. Also available on Hugging Face. Once again, PyTorch to keep things consistent through our pipeline. And we'll be using the Hugging Face model handler here as well. So, if we look across our pipeline, we could now rewrite it in terms of the models we're using and the data format that is on each of the edges that connects those models together. So here we're going to start with data in Google Cloud Storage as WAV files. We're going to send those WAV files to the OpenAI Whisper Small model using the Hugging Face Pipelines model handler. That will output text that we'll send to XGBoost with the XGBoost model handler pandas. Looks like my slide didn't quite line up there, my apologies. The output of that XGBoost model will be the class, the type of request, as well as the text. Those will be sent to a variety of small LLMs, and then those LLMs will output text that is the answer to the user's request. Finally, that text that is the output of the LLM will be sent to the MMS TTS English model. Then we will produce as our final output WAV files once again. Now, I've talked about a couple of different models or notebooks here in the talk. So in this last slide, I just include the links to the various models and notebooks that I used in the talk. I hope you can find these helpful, and we'll go into actually writing the pipeline in sessions 4 and 5. Thank you very much, and I'll see you again soon. Okay.